Good morning, all of you. I hope you are doing well. Today, I've come again. Today, the new session is that Newton's law of the gravity force. Okay, this is the very vital force. This law has been invented by the our famous scientist Isaac Newton. Okay, Isaac Newton has established this law. Let's see, move on. What is the law? Okay, every object in the universe attracts every other object with a force directed along the line of the center for the two objects. That's that's proportional to the product of their masses, okay, and inversely proportional to the square of the distance between two objects. Newton's law, it has been stated that we know that every object or every particles of a universe, they are the attracted to each other. This attractive force is that if the two object mass is difference, let's see, object 1 is m1 and object 2 is m2. Okay, there is very there are defined of mass. Okay, and this is the product of the mass. This is the product of the mass. It has been said that the force, Newton's law of gravity force, is proportional to the product of the defined two masses of a universe. Okay, defined two, let's see, m1 is the defined mass and another mass is m2. Okay, this is the product of the different value of the masses of the two body in the universe. Okay, uh, another statement, it has been said that the the force is inversely proportional to the difference, the distance between the two masses, 1 by, sorry, the distance of the square distance of the two mass. Okay, let's see, have graphically, this is one particle and this is another particle. Okay, this the value of the mass is, let's see, m1, and also the value of the mass is, let's see, m2. This the attraction force between two mass is, first, okay, F proportional to the product of the m1 into m2. Next point, the distance between the two mass, let's say it is the center point, also it is the center point. This is the distance between the two mass. Okay, this so second statement, it has been said that F inversely proportional to the square of the distance of the two masses. Okay, this is the main law. This, have a look, so it will be clear to understand. What was the first statement? F proportional to the product of the two masses of any two object of it, m1 and m2. And second statement was that inversely proportional to the distance square. Okay, this body and this body, m1, and this is m2. This is the center point, also this is the center point of this, the distance between that d. Okay, so if we add this two equation, this is first one equation and this is second one equation. Okay, if we add these two equation, f proportional to d square, sorry, m1 m2 by d square. Okay, this formula will be like this. Okay, if we eliminate this proportionality limit, then f equal to g constant g into m1 m2 by d square. G here, g means here gravitational constant. Okay, gravitational constant. G means gravitational constant. Here the value of the g is that 6. Value of the g is that, here value of the g is that 6.7 into 10 to the power minus 11. Okay, 6.7 into 10 to the power minus 11. Okay, this is a gravitational constant whose value is 6.7 into 10 to the power minus 7. Here let's see, as per example, here I have drawn the equation was that f equal g m1 m2 by d square. Okay, the we know that g is a gravitational constant, also its value is 6.7 into 10 to the power minus 11. Okay, so right here you can write g m1 by d square, we take it as a single value g. Okay, it is the same m2 g into m2. Okay, g means gravitational attraction force. Gravitational attraction force, as for example, the earth every particles attracts to its center by the gravitational acceleration, gravitational force. Okay, this g, the value of the g is for the earth is 9.81 Newton. Okay, 9.81 Newton. Actually, this gravitational acceleration, the gravitational force is defined for the different particles. As for example, earth, the earth and on the earth, earth for the moons which is rotating around the earth, the gravitational acceleration is, the earth is attracted to the moons is 9.81 Newton. Okay, you can show in another solar system that the gravitational force will be defined. Okay, so okay, thank you.